Hello again, welcome to my class. This is Teacher Hura, and in this video we shall learn about how to convert from moles to molarity and the volume of solution. Now in my previous video I had showed you on the meaning of molarity and the meaning of concentration. So it's going to be very important to remember that molarity is the number of moles of a solution in 1 liter. So remember that, it's very important. So let's use some few examples and show you how you can interconvert between these three. So for the first example, you have that calculate the molarity of sulfuric 6 acid obtained by dissolving 19.6 grams of the acid in 200 cubic centimeter of solution. And right here in brackets, you've been given the relative atomic masses of hydrogen, sulfur, and oxygen. Now, as I said, if you're calculating the molarity, it means that you need to calculate the number of moles in 1 liter of solution, or rather we can say in 1,000 centimeters cubed of solution. So let's start right off. The first thing we need to calculate is the number of moles. So number one, sulfuric 6 acid is written like this, the formula. So you need the number of moles of sulfuric 6 acid in the 200 centimeters cubed. So that is your first step. And that one is easily obtained. You can remember again in some of my previous videos, the easiest way to calculate the moles is just to use the formula. The number of moles is equal to the mass in grams divided by the relative formula mass. Now in this case you've said relative formula mass, but it could also be relative atomic mass, relative molecular mass. Now how do you get the relative molecular formula mass of sulfuric 6 acid? We shall take these relative atomic masses and multiply them. So like the first one right here, we have 2 hydrogens and each of them is 1. So we'll say 1 times 2. And then we add the one for sulfur, which is 32. And then we add 4 oxygen. So we have 4 times 16. When you get the total here, is going to be 98. So the relative formula mass of sulfuric 6 acid is 98. Then to calculate the moles in 200 cubic centimeters is going to be very easy. We've already been given the mass right here as 19.6 grams. So we'll substitute and have it like this. So you can see, and there you'll be able to obtain the number of moles of sulfuric 6 acid in just 200 cubic centimeters. So when you punch this in the calculator, you end up with 0.2. So that is the first step. The second step in this question is now to calculate the molarity. Now remember, the molarity is the number of moles in a liter, which is 1,000 centimeters cubed. So now it is going to be easy for us to do this because the number of moles you have obtained right here are present in 200 cubic centimeters. So the question is, how many moles would be present in 1,000 cubic centimeters? So we'll say 0.2 moles are present in 200 centimeters cubed. Now the question would be, how many moles would be present in 1,000 cubic centimeters? Now, I'm sure you already know, if you have these two statements like this, the next thing is to cross multiply, and you'll multiply 1,000 by 0.2, then you divide by 200. So it's going to be So now, once you have this expression, remember, you're going to get your answer right here in moles per liter. So we'll cross the centimeters cubed out, and of course this one goes by 1, and here it goes on 5 times. So when you multiply 5 times 0.2, you end up with 1.0. So this is going to be moles per liter, because now we're dealing with moles in 1,000 centimeters cubed. So this can also be written as 1.0 with a capital M to show us that this is moles per liter. So that is the first one on how to calculate, and you are converting now between the number of moles and molarity. So let's head to the second one. Now in this second example, we are supposed to calculate the number of moles of hydrochloric acid contained in 50 cubic centimeters of 0.2 molar HCl. So you can see that this expression right here, 0.2 m HCl, means 0.2 moles per liter of hydrochloric acid. So now it's going to be very easy for us to do this. So you'll say 0.2 moles of HCl, that is hydrochloric acid, are present in 1,000 centimeters cubed. Now the question would be, how many moles would be present in this volume right here, 50 centimeters cubed? Once again, the cross multiplication comes in, and we have 50 centimeters cubed multiplied by 0.2 moles, and this is going to be divided by 1,000 centimeters cubed. So as you know, we'll again cross out the cubic centimeters and end up with our answer right down here in moles. So that is now, if you cross multiply this one, you can divide this, you get 1, you can divide this, of course you get 20, and when you divide this you get 0.01 moles. So that is how you calculate the number of moles. So this is the conversion now between the number of moles and the volume. So you can see we are now obtaining the volume and the number of moles being related in this question. Now let us head to another example. In this third example, you're supposed to calculate the volume of 0.5 molar sodium hydroxide that contains 0.001 moles of the solute. So the logic is the same in this one. When you're converting between moles, volume, and the molarity, the logic is the same. So here we'll say that 0.5 molar sodium hydroxide means that 0.5 moles of sodium hydroxide are contained in 1,000 cubic centimeters. So now if that is the case, the question would be, what volume would contain 0.001 moles? So you'll put the 0.001 moles on this side. So this is another case of cross multiplication, and you'll have that 0.001 multiplied by 1,000 divided by 0.5. So there again, you'll just punch this in the calculator and cross out your moles and end up with your answer there in cubic centimeters. So once you do this, you'll end up with 2.0 centimeters cubed. So, and that is how you convert between moles, molarity, and the number of, and the volume of solution. So well, you can see that we have been able to convert between the moles, the molarity, and the volume of solution. Now, if you learned something in this video, make sure you give it a thumbs up. If it is your first time, don't forget to subscribe. Ring that notification bell so that whenever I upload any new videos in chemistry, you're going to get them. So make sure that these kind of questions never give you trouble anymore because they're very simple. Now, until next time, bye.